Good day everyone. Today I will explain to you validity coefficient. The validity coefficient is the computed value of Pearson product moment correlation coefficient. So in symbol we have R sub xy. So here is the formula for Pearson product moment correlation coefficient. So we have here R sub xy is equal to the product of n and then the summation of xy minus the product of summation of x times summation of y over the square root of n times summation of x squared minus summation of x quantity squared, okay, times this n times the summation of y squared minus summation of y quantity squared. So R here is the correlation coefficient. And N refers to the number of pairs of your data. X, the values of the X variable in a sample. And then this one, X with a bar. We have here the mean of the value of the X variable. And then Y, the values of the Y variable in a sample. And Y bar is the means of the values of the Y variable. Summation of X means that you have to add up all the X scores, and the summation of Y means that you have to add up all the Y scores. Summation of X squared means that you need to square the X scores before adding them up, and then summation of Y squared means that you need to square the Y scores before adding them up. And we have here also summation of xy, which means that you must multiply each x score by each y score and then add them up. So this is called the cross product. So we have here example. Teacher Benjamin James develops a 45-item test and he wants to determine if his test is valid. He takes another test that is already acknowledged for its validity and uses it as criterion. He conducted these two sets of tests to his 15 students. The following table shows the results of the two tests. Is the test developed by Mr. Benjamin James valid? Find the validity coefficient using Pearson R and the coefficient of determination. Okay, so we have here the table. So we have here student. So we have 15 students. So our n is equal to 15. So here are the scores of 15 students for the first test. And then this one, the scores of students for the second test. So notice that student 1 got 12 in the first test and then 16 for the second test. Student 2 got 22 in the first test and 25 in the second test. Student 2 got 22 in the first test and 25 in the second test. The third student got 23 in the first test and 31 in the second test, and so on. So we need to get the summation of X. So how do we get this? So you have to add 12 plus 22 plus 23 plus 25 plus 28 plus 30 plus 33 plus 42 plus 41 plus 37 plus 26 plus 44 plus 36 plus 29 plus 37. So the summation of X here, if you get the total of this, so we got 465. And for Y, so all we need to do is to add all of this, 16 plus 25 and so on up to 41. So the total will be 508. So therefore, summation of Y is equal to 508. So for xy, we need to multiply the value of x and y. So in this case, for student 1, so our x is 12, our y is 16. So 12 times 16 is 192. For the second student, 22 times 25, 550. For the third student, we have 23 times 31, 713, and so on. You multiply your x and then your y so that you can have the answer for your xy. So if we will get the total of this, 192 plus 550 plus 713 and so on up to 1517. If we get the total of this, it will give us 16,702. So the summation of xy is equal to 16,702. So for x squared, how will we get x squared? So all we need to do is to multiply x to itself. Okay, 12 times 12, so we multiply it 2 times, equals 144. 22 times 22, 484. 23 times 23, 529, and so on. So 25 times 25, 625. 28 times 28, 784. Okay, and so on. So we will get the total of this. We will add 144 plus 484 plus 529 plus 625 up to 1,369. So we get the total of 15,487. So the summation of x squared is equal to 15,487. So for y squared, we will multiply also y to itself 2 times. So 16 times 16 is 256. 25 times 25, 625. 31 times 31, 961, and so on. So we will get also the total of this. We will add all of this. The result will be 18,162. So summation of y squared is equal to 18,162. So let's substitute in the Pearson product moment correlation coefficient formula. So we have here n. So our n is 15. So we will just substitute it. We will put 15 here, or we will write 15. And then we have here summation of xy, which is equal to 16,702. Okay, minus summation of x, which is 465. Okay, and then summation of y is 508. Okay, so we have here n, which is 15, and then summation of x squared. Okay, summation of x squared is 15,487. So we have 15,487 minus summation of x. Summation of x is 465. Okay, quantity squared. Okay, times 15, because our n is 15, times summation of y squared, which is 18,162, minus summation of y. So summation of y is 508, quantity squared. So we will multiply 15 and 16,702. The product is 250,530. Okay, minus the product of 465 and 508 is 236,220. Okay, and we will go to the denominator. 15 times 15,487 is equal to 232,305 minus, so 465 times 465 is equal to 216,225 times, okay, we will multiply 15 and 18,162. So the result is 272,430. So 508 squared means 508 times 508, which is equal to 258,064. So, we will subtract this. So, 250,530 minus 236,220 is equal to 14,310. And we will subtract this also. So, 232,305 minus 216,225 is equal to 16,080. And also, 272,430 minus 258,064 is equal to 14,366. So we have 14,310 divided by square root of 231,005,280. So we multiplied 16,080 by 14,366. So that's why we got 231,005,280. So we will copy 14,310, okay, divided by the square root of 231,005,280 is equal to 15,198.85785. So 14,310 divided by 15,198.85785 is equal to 0.941518 or 0.94. So therefore, our correlation coefficient is 0.94. To get the coefficient of determination, we will just square 0.94. So 0.94 times 0.94 times 100% is equal to 88.36%. So our interpretation, the correlation coefficient is 0.94, which means that the validity of the test is high, or 88.36% of the variance in the student's performance can be attributed to the test. Please watch the reliability coefficient lesson in the next video. Thank you.